Hello 8th graders. In this IXL support video we're looking at F11, and IXL calls this the power rule. I call this the exponent to exponent rule, but powers, exponents kind of mean the same thing. So when IXL says power rule, they're talking about what happens when we apply an exponent to another exponent. That's what people mean by the power rule. When you have one exponent applied to another power or applied to another exponent, what is the rule for handling those powers or those exponents? And before we jump into this, a few examples on IXL, I wrote out a simpler problem that can kind of help us make sense of the property or the rule first for this. If I had x cubed, or x to the third power, and I squared it, I applied a second exponent to that exponent term, that would mean I need two copies of x cubed multiplied together. So I've written this out a little more here. I took x cubed squared, and I wrote it out as x cubed times itself, x cubed times x cubed. And you may remember from our multiplication rule, if you have the same base multiplied, 3 copies of x times 3 more copies of x, all you need to do is add them up. 3 copies of x times another 3 copies of x says I have 6 copies of x. But some of you may be saying, wait a minute, there was a shortcut here. If we had just done 3 times 2, if we had taken the original exponent and multiplied it with the new exponent that was applied, we could have gotten our answer without this middle step that you see right here. We could have cut out this entire middle step, which wasn't super long, if we realized that when you do an exponent applied to another exponent, all you need to do is multiply them. Now I want to show that example in our notes. That's actually Rule 6, or the last property we have here for our notes. Whenever you apply an exponent to an exponent, all you need to do is multiply the two exponents together to figure out the exponent attached to your final answer. So we're going to see a few of those in actions here, but this rule is pretty straightforward and works quite well. So here, if I see 3 to the 9th raised to the third power, I could write out, if I really wanted, 3 to the 9th times 3 to the 9th times 3 to the 9th. And that gets a little weird. They're not letting me do exponents, so I could write that out as 3 to the 9th 3 times, and then I could add up all of those 9s together. 9 threes times 9 more times 9 more. 9 plus 9 plus 9 is a total of 27 copies of 3 multiplied together. But the easier way to get there would have just been to have taken the original exponent, 3 to the 9th, and multiply it by the new exponent being applied. 9 times 3, if I have 3 sets of those, I'm going to have 27 total copies of 3. So moving forward, I'm going to switch more to our shortcut. I'm just going to recognize, hey, if it's 3 to the 4th power all raised to the 9th power, all I really need to do is 4 times 9, which is 36. We have 9 sets of 3 to the 4th, or 9 times 4 says we're going to have a total of 36 copies of that. Sorry, that took a minute for me to enter. All right. Next one, 6 to the power 5, all raised to the power 9 with those parentheses. What they're really telling us here is, hey, take 5, multiply with 9, because we have 9 sets of 6 to the 5th. Or in total, we're going to have 45 copies of 6 that are multiplied together. I'm going to skip ahead here. I think y'all are great on this at this point. I would encourage you, before I give the answer, to think about what would 2 to the 6th power, all raised to the 3rd power, be. Try to do that on your own right now. But hopefully most of you are saying, Mr. Doherty, all we had to do was do 6 times 3. Which gives us 18, and that's how we got 2 to the power of 18. So you're in good shape at this point. You could definitely do F11 on your own, and we're going to go ahead, skip ahead up towards the challenge zone, see if there's anything that they throw at us that's more difficult, but I'm not sure if they do on this assignment. So now we're up at 75, we're in the 70s. It's the same type of expression, an exponent raised to another exponent. The only thing that's annoying is they're making you do this with bigger numbers. So pause the video, figure out what would 2 to the 14th raised to the 11th power be. And as you're coming back and have that answer on your own, you probably just did 14 times 11 to get to the answer. And if 14 times 10 is 140, I could add one more copy of 14 and get 154 here. And that's how I'm doing the mental math of 14 times 11. Lots of ways you could do 14 times 11. And I'm going to go ahead and say 2, I hope I'm right, 2 to the power of 154. And it doesn't let me skip ahead anymore, and you see all they're doing annoyingly is just kind of putting the exponents a little bit larger, making you think more when you multiply those two exponents together. And I'm sure a bunch of you are saying, hey, this is 1 to the power of 55 when I do 11 times 5. And I'm not going to keep going any further on F11. Y'all are in great shape. Thank you for crushing it and doing strong work on F11. If you do happen to have any questions, of course, my email address. I'm always available to work with you if the video is not helpful. And that email address is ddoherty3@bostonpublicschools.org. Or even better, you could just send me a Google Hangout if you're a Mildred student, and then that Google Hangout chat I get even more quickly than the email. Thanks again for watching to the end of the video. Keep up the awesome work.